Yeah, so after this break, I want to talk about briefly with you about agentic industrial equipment onboarding. My name is Hubert Asamer. I work as a solutions architect at AWS since 6 years. I'm based in Munich, Germany. And I'm within Steve's team now since September, so focusing more on global customers. And I've learned a lot in the last 6 years because I was 25 years ago in my school or in my education a machine builder somehow, a mechanical engineer. But I left this and now I'm back. And what I see out there is typically, not this. I see this is the perfect world. We all want to be, right? And our most advanced customers, they have highly sophisticated production lines. Everything is automated, standardized equipment, telemetry is collected from the equipment. The data is context aware, so every data set you see in some data store is always trackable, traceable where it was and where it comes from. That's super cool. Everybody in the company, has access to all the data, to all numerical data of PLCs, for instance. I'm not talking about personal data there at all. The telemetry data that is sent to the cloud or anywhere already solves real business problems. So we are sending massive data. We are doing training of machine learning models. We're doing extensive analytics, bring back knowledge to the edge, make the machines, the robots, the equipment in general more intelligent. This is all the goal about, right? And sometimes we forget about that. But this customer, the perfect one, they solved all that. And the equipment gets better over time. What I see out there when I'm at the longer tail of customers is the reality is a bit different. You have, different vendors of automation equipment, different regimes, how to collect data. Access to data is highly restricted, even if it's only numerical PLC data, any float value, or you need to get a permission to view a float value or something, or even connect to a dedicated equipment. So, this is the reality by some of my customers, right? And especially the onboarding of equipment, when they want to onboard existing brownfield equipment to a newer data collection system takes forever. We see also that bigger ones are really struggling when it's about to not replace the PLC or so, but they have a new pattern in collecting data and they want to include all this equipment into this new data machine, like a, let's call it a new namespace or unified namespace, let's call it a different thing. It's very cumbersome to onboard this equipment, and the context is not there. You have the ingested data is if it's ingested, it's somehow stored in a database. It's not consumable for data scientists, for other workloads. And finally, we want to do in this time now something with AI, with LLMs. This requires highly contextualized redacted data sets, right? And this isn't there often the time. And so it's really crucial to solve that underlying path, to go higher in the stack and solve real business problems. And most manufacturers are in between somehow, between this perfect world and this really bad, sad state on the left side. And I learned that this new patterns out there can help us solving that challenges, right? And I defined a moonshot goal, right? I'm the CEO of a company. I want all employees in my company have access to all equipment telemetry data of all sites, all the time, without exceptions. This sentence is really bold, I know. The data shall easily accessible in tabular form over time. It should be really easy to do time series analytics. I want the data in Iceberg. It's a proper nice format. The cloud is really good built for that, for storing that. We released some nice services there recently. I also want to connect to the real-time state. So I have this historical data lake layer. I have this real-time layer. I want to consume both of that, right? And I want my equipment onboarded within 5 minutes. And I want immediately get telemetry data out of that. I want the data. I want the data immediately flowing to the Iceberg data lake. That would be a perfect state, right? And I have a requirement too. All site level data needs to be exposed at OPC UA. Okay, how do we achieve that in a brownfield environment, in a non-standardized environment, where you have partly OPC UA-based equipment, where we have MQTT, then you have file-based storages. It's really sometimes really hard to do that. So we have these challenges. We have the data collection challenge. Data collection challenge, it means connecting to these industrial protocols. There are various solutions out there. I will show you one of them, which is SFC, which is our open source framework for connecting to industrial protocols and sending this to cloud targets or other targets. This is just one of the solutions. We have many other solutions there, from Process, from our partners, from Litmus, from Hubert. Yeah, most of you know this. And yeah, we have the domain knowledge challenge. This is one of the biggest challenges we see. This won't fix, because the skilled staff, the skilled personnel gets less over time, knowing what exactly is ongoing within this complex equipment. We have seen customers trying to cope with that, right? Sorry. Okay, sorry. Well, they cope with that with trying to fill some knowledge bases with historical documentation, PLC, logic diagrams, feeding this into knowledge bases, working with LLMs and agentic solutions. This can help to some extent, but won't replace the skilled workers. This is a problem. Yeah, I cannot show any solution to it right now. The OTIT configuration and coding challenge. If we have an OTI connectivity solution, like for instance SFC, or other solutions that are really configuration driven and have a strict scheme for how the configuration needs to look, this is a good solution where LLMs nowadays can help for achieving the 85 to 90% correctness of a configuration, of doing this heavy lift of mapping approaches, because it's always a mapping effort you need to do from this PLC data block specification into some other format, be it in companion spec or other schemes or other payloads or other standards you need to comply with, right? And the data sharing challenge. Once you have ingested the data somewhere, for instance to AWS, and then, yeah, okay, how to share this data properly? This is also a real challenge. And the AWS platform, all the cloud vendors nowadays solve this, because the services are built around it. All is about data, right? Good. Let's start with SFC. I hope most of you in this room know what SFC is. SFC is a open source industrial connectivity solution, which has a tool set of southbound connectors and a tool set of northbound connectors. Those northbound connectors are typically cloud targets. Yeah, most of the time, our services like IoT Core, IoT Sitewise, the S3, right? So it's a mixture of MQTT, of HTTP batch upload to the cloud, and in between you have the SFC core that can manipulate that data, right? This SFC framework is configuration only. It allows for extensibility. It's a Kotlin framework. We released everything as open source on GitHub. And if you like, you can write your own adapters for dedicated protocols. The Kotlin interfaces are there. You can extend it very easily. And you can also integrate IPC connectors when you write your own adapter in C# or another language. It's possible to incorporate or to communicate with the SFC very easily. Okay, so this is the architecture, the adapters, the target adapters. So pretty clear most of the time, and the core is responsible for receiving configuration and doing the filtering aggregation. Right, here's the concept. We have defined in this configuration specification. We do have a schedule. A schedule is where we relate the sources with the targets. In that case, we have, for instance, an OPC UA source. I want to have all tags within this OPC UA source that are defined in another section in this JSON document sent to 4 targets in that case. So do a fan out of a single source to a target. And this is typically running in an edge gateway. So SFC can be deployed as a container on an edge gateway in an industrial PC. It connects to the equipment. You can do aggregation, filtering, and then you send it to some targets. Right. So the core maintains configuration, the logging, the metrics. So you can create metrics of your ingestion or of your data collection. So you can immediately send these metrics, these logs to CloudWatch, to our logging service in the cloud. Then you see the metrics immediately, how your ingestion is ongoing, if there are any issues, if you are out of your boundaries of tolerances. Right. The protocol adapters, they can also run standalone. All the components of SFC can also run standalone. So you can deploy a protocol adapter as a Kubernetes service, for instance, or you can deploy a target adapter as a Kubernetes service or as a scalable service, so that you can, make this available for more data collection pipelines. Right. Here we have the list of supported protocols. We are constantly extending it. So most prominent is Siemens, the Beckhoff native ADS support. We have also Mitsubishi support. We have the Rockwell Ethernet IP, and we have other more open protocols like MQTT or REST that you can collect to. Target adapters, same story here. These are the typically AWS-focused targets. We see a big focus on IoT Core, of course. That's our MQTT broker, our managed one. Immediately ingest data to it. Sidebys for our industrial customers, an important service where you define your asset models and have an HTTP batched upload to Sidebys. But also many customers are simply uploading batched data to S3 and working with their data lake and ETL pipelines to properly create data sets. Recently, we released the S3 Tables service, and we also released an S3 Tables adapter, which gives you immediate upload or immediate ingest to Iceberg. And the S3 Tables service creates a managed layer for Iceberg data. So your data scientists, your machine learning engineers, your AI experts immediately can consume the data from S3 for their use cases. And with this pluggability of SFC, it's really easy for, let's say, use cases that are coming up when you discover the data. When you skim or browse through the data in the cloud, then you see, okay, this might be a use case because there is this and that anomaly. Then they want to change the frequency of the collection regime at the edge. So typically in the past, this was a process of months to change the collection from the SFC or from the edge gateway that collects from the equipment. So we see that our customers are doing that on the fly with structured CSD pipelines, with Greengrass, for instance. Greengrass brings this code, this deployment of SFC easy to the edge. So we see a big trend there to immediately change the whole collection regime. Good. When we talk about agentic, because this title of this presentation says agentic, okay. SFC is config driven, has a very rigid and strict JSON config specification that's linked in the GitHub repo. So typically all what is text and good documented, like the SFC repository has a rich set of markdown files. This is a solid base for an LLM to produce SFC configs. And this could be a good solution to speed up the onboarding of equipment. And that was the use case. We tested this out earlier this year. Is it possible for a not so much technical person to simply prompt an agent and say, I want this S7 PLC to be onboarded with this and that IP address. I have a PDF document of the data blocks that are in the PLC. Please create a valid SFC configuration, immediately connect to this PLC and collect the data. With agents, this is possible. To not 100% deterministic correctness, no way. We are in an LLM, that's a language model. There is no, everybody that says that can replace a a skilled worker is wrong. So LLMs are really good to get a first shot without training, without any training, a first shot correctness of, I would say, when you give it a proper context with MCP servers, where you can bring the knowledge to the model, to the language model, to 80 to 85% correctness, right? And the agent is typically a application that runs in a loop and constantly iterates the context or the findings, the results with the model, and the model responds, and this is we call it the agentic loop. And we have released earlier this year the Strengths SDK. With Strengths Agents SDK, it's very easy to create agents. And yeah, everybody can now create an agentic application. You give this agentic application an MCP server. An MCP server is a methodology to bring the tools where an agent can act on in a structured way to this agentic loop, right? Because sometimes the agent reasons about the problem because it gets a prompt, and then the problem says, okay, I need this and that tool that I can solve this, and the MCP brings these tools to the agent, right? And that's what we created earlier this year. It's a demo, and I want to briefly show this to you right now in a very short demo. We have an S7 PLC, we have a backup PLC, we have two Windows instances where these are running. The Siemens one is a PLC sim simulator one. The backup PLC is running in the TwinCut, the Windows instance. And I want to onboard the S7 PLC. That's one task. And I only have a CSV file where my data block is specified with the offset, with the bit offsets. That's all I have, and I have the IP address. And I want to then collect all the data from the backup and from the S7 PLC and want it exposed as a OPC UA server at the site level, right? And SFC has an OPC UA target. It's very easy. You just turn on all the data you collect. You can immediately expose as an OPC UA endpoint, which gives you a first shot node hierarchy. I will show you this briefly. And then we collect the data with SFC and send it immediately then to the cloud. In that case, to Kinesis, because to Firehose, to a batched upload to S3 tables, so that we immediately have the data in Iceberg. Okay, let me briefly switch over there. I'll try to connect now to one of the PLCs. This should be the backup one. Right, you see the PLC TwinCut there. It's running. We want to get this data out immediately. Then we have also the S7. Where is it? Let's briefly connect to the S7. Okay, I have PLC sim running, and I have 5 PLCs there, and I see one of them, is connected online. So this I want to get into SFC and then send to Iceberg immediately. In the past, this was a cumbersome task, and nowadays I have here a Visual Studio Code running in the cloud. I can do, this is my industrial PC, right, where SFC is running, and I have here the SFC wizard running, and I could prompt it now. I will do this not now because it takes some time, takes roughly 1 minute or so. I prompt it with the problem I have, right? I have an existing SFC pipeline which collects me the data from the backup PLC, and it prompts out to standard output. And I have a CSV file that looks like that here, which describes my Siemens PLC data block variables I want to read. And please read out and create me a new configuration that combines all this together in one payload, right? And the output looks like that here. It creates a file that is called multi-PLC. So this is then created by the agent. And here you see a valid SFC configuration, which has a schedule defined where I have the backup source, the S7 source, and in the backup source, is already existing, and the S7 source is newly created by the agent, right? And this is then because the agent reaches out to the MCP server, and the MCP server gives it the JSON specification of the what is required for SFC, and does all the other stuff for you. And this is typically a very cumbersome stuff to create manually, right? And the agents are really good in that because it's text at the end like code, but we need a more structured way. That's why we give it an MCP server. Output is pretty solid, I would say. And now let's test it. And maybe we run the OPC UA server. So I have now this multi-PLC running, and I see here an OPC UA target is activated, and the OPC UA target is exposed as a local port, right? So I have here an OPC UA server running. I will briefly show, and then I do catch this port because that's an EC2 instance. Now I have a laptop here. I use Systems Manager to fetch the port forward to localhost that I can browse the data with my process client on my MacBook here. Okay, I connect. And here I see the two PLCs that are running in this Visual Studio Code in the cloud. I have the tags from backoff. Can immediately then monitor those. Should be working. And also I see the Siemens tags. The ones that are set to the language model, please add this to the configuration and add to the data pipeline. So that was a very brief demo. And also it created a firehose target in SFC that we sent this to our firehose and to the data S3 tables service. And we see this here. We have a tables bucket. This tables bucket is an iceberg table. And in this iceberg table, I see now, that's the data from yesterday. It's a bit of a lie, but you see, if I would query it with Athena, you would see that it is ingested to iceberg immediately from SFC. So we saw now a twofold demo. One is using the agents or an agentic application to extend existing configuration or to create new one, to combine multiple PLCs or multiple equipment, expose this as a local OPC UA server, connect to this OPC UA server, and then also send all data to the cloud, all data that I want, right, for a given use case, and expose immediately at the data layer for my analytics. And with that, I say thank you.